Okay, you found the answer key video. Hopefully you've done the work already. So let's check it out. Let's look at number 1. So I'm solving for x. It's on both sides. And regardless of which side I look at, there's an exponent of 1/4 on both sides. Okay. By the way, what does that exponent of 1/4 mean? Good. The numerator represents the power of 1. The denominator represents the root of 4. Good. Okay, so remember, we are just going to apply the principle of fractions. If I want to get rid of the fraction 1/4, you would simply multiply by the reciprocal. Excellent. So on both sides, I am going to multiply by 4/1. And remember, when you have exponents through parentheses, this is a simple multiplication problem, which means you get 4/4, which is simply, 1. Yay! So you end up with a simple equation of 6x minus 1 equals 2x plus 15. You've probably done this type of problem in your sleep so many times that you're like, hey, the answer is... Okay, but let's work it out. What do? Move the 2x to the left. I agree. So we have 4x minus 1 equals 15. Then what do you want to do? Add the 1. And then what do you want to do? Divide by 4. Wonderful. Are you done? You're right, you're not. I need to check this 4 and make sure that I get the same answer on both sides. So, over here on the left, 6x minus 1. Well, that's 6 times 4, right? What's 6 times 4? 24 minus 1 is 23. So you have 23 to the 1/4 exponent. Got it. Over here. X is 4. So 2 times 4, 8, plus 15, 23. So yay, we have the same thing on both sides. We're taking 23 to the 1/4 exponent. Yeah, get the calculator out, but I'm not going to worry about it. All I care is we got the same answer on both sides. Good? Okay. Number 2. Okay. In this case, I have an exponent of 3/5. What's the 3 mean? Third power. What's the 5 mean? Fifth root. Good. Excellent. Regardless, I'm solving for x. X is in the parentheses. I need to get the parentheses off, which means you got to get rid of the 3/5 exponent by, good, multiplying by the reciprocal of the fraction. Like I said, it doesn't matter that this fraction is in the exponent position. I am still going to take the reciprocal, but I'm going to raise it to that power, because when you have powers through parentheses, it is multiplication, which means these guys cancel, and I have a simple, good, you have a simple 1 as a power now, which means you have 2x plus 3 equals 8 to the 5/3 exponent. Good. And you're like, okay, how do I deal with 8 to the 5/3? Remember, 5 represents the power, 3 represents the root. Gratefully, it doesn't matter which one you do first. If I take 8 to the 5th power and then take the cubed root of that answer, it's the same as if I took the cubed root of 8 first and then raised it to the 5th power. Me personally, and I'm going to do some side work over here. Me personally, I like to take the cubed root of 8 first and then raise it to the power of 5. Why? Because I can do the cubed root of 8 without a calculator. That's 2. And then I still have to take 2 to the power of 5, which is, good, 32. Which means over here, your equation is 2x plus 3 equals 32. And then you get to finish solving from there, right? Okay, are we good with this? Here's the deal. I don't want to take 8 to the power of 5. Are you kidding? That's a lot of calculator work, and I get the calculator can handle it, but if I'm on an exam, I need to work smart, not hard. Yeah? Yeah. Okay, let's finish this off. Good, -3 on both sides, which gives you 29. Then divide by 2, and if they don't ask for a decimal or a mixed number, you leave it as 29 over 2, right? Okay. But now we have to check this. So if you don't mind, I'm going to check number 2 right here. So you have 2 times this lovely fraction, and then you have to add 3. Don't these cancel? So I have 29 plus 3, don't I? Which is what? 32. And then I've got 32 to the 3/5 power. Well, if I work backwards, I'm just going to get 8. This answer checks. Cool? Lovely. Okay, one more for you. Tell me what you're going to do. Excellent. You're like, hey, this is getting monotonous. I know I have to raise it to the exponent of 4 over 3. You're right, you do. And that leaves you 3x minus 2 equals 8 to the 4 over 3. How are you going to figure that out? Yeah, you're like, well, isn't it the same? You're right. It's basically the same, except the power is 4. So I would take the cubed root first, which gives you 2. But now I've got a power of 4. And 2 to the power of 4 is 16. So we have 3x minus 2 equals 16. How are we doing? So far, so good? Okay. And add 2. You're like, oh yeah, we're not done. You're right, we're not done. You thought that was victory, but we're not done. And good. Are you done? Nope. Gotta check it. Okay, we can handle this. You're on a roll. You're getting the hang of it. Okay, 3 times x. That's 3 times 6, which is what? 18 minus the 2 to the exponent of 3 over 4. 18 minus 2 is 16 to the power of 3 over 4. Okay. Third power, 4th root. You're like, hey, you're right, it is the same. What's the 4th root of 16? 2 to the power of 3, definitely 8. This answer checks. Cool? Lovely. I got one more for you, if you noticed in those examples. Little bit of a brain teaser. Be right back. Okay, here's that 4th example. Little bit of a brain teaser. Remind me of something. What does the 1/2 exponent mean? Yeah, first power and the square root. So here's how I'll tackle this. This is how I like to tackle this one. I like to literally write with the square root. It's easier for my brain to see it with the radical than with the exponent. Okay? All right. So this is the equation I'm actually solving. Now, I have 2 radicals in here. And yeah, I'm going to have to square it to get rid of it. But here's something to remember. This subtraction sign acts like super glue. It doesn't let me pull those apart. It doesn't let me look at them separately. I cannot square each of these individually. You just can't. Subtraction and addition, they may be easy, but man, are they the pickiest operations. They're easy, but they're the pickiest operations to work with. So here's the deal. I would literally need to square the entire side. Yeah. That's a binomial, which means you'd have to write that twice. That's not very pretty. So here's how I tackle problems like this. I'll move one radical to the other side. You're like, which one do you move? Well, the one that's got the minus sign in front of it, I'm going to move it because I'd rather it be a positive. So I am going to add that radical to the other side. Got it? And now I'm going to square both sides because the second power will get rid of that second root or square root. Yes? Okay. Now, the left side is easy. It's just x plus 3. The right side is the challenge. Because when you remember, if you remember squaring binomials, binomial means two terms. That square means you have two of these parentheses. So to make certain we do it correctly, we literally need to write two parentheses and do our distribution. You're like, that doesn't look pretty. Yeah, it's not bad. You just have to take it slow and be cautious. So, remember, this 2 is going to get distributed to that parenthesis, right? But so is this square root of x minus 5 going to be distributed to this parenthesis. Sometimes it's good to look at them as two problems. Okay, so when you distribute, you'll get 4 plus. Now, there's a 1 there, isn't it? Think of this whole radical like a variable, like a 1x. 2 times 1x would be 2x, right? Well, that would be 2 times your root. You can't get inside the root because the 2 is not a root. This one. When you square this one, I'm going to write it here, you have this variable times 2. So just like above, you got 2 times that variable, don't you? And then you've got this square root of 5, pardon me, square root of x minus 5 times itself, or squared, don't you? Okay, let's put it together a little bit. 4 plus 2 times the square root of x minus 5, plus another 2 times the square root of x minus 5, plus, what happens when you square a square root? Good. So you just have x minus 5 because it cancels, doesn't it? Excellent. Okay, talk to me. We have like terms, and some of you are like, well, right away, we have the x, we have the 4 and the negative 5, and then we have these two radicals. Well, what's 2x plus 2x? Yeah, 4. Cool? This is a process that you must take slowly, okay? I break it out into 2 distribution problems. Here's the first distribution, here's the second distribution, and then I recombine it here, the 2 answers, all right? I'm a visual person. I need to write every step out, and I need to take it slow. Cool? Okay. So this binomial squared turned out to be this answer here. Okay, but I still have the square root in the problem, which means you're going to have to do what? And you're like, no! Yeah, you have to square it again. Now, mind you, would it be better to leave everything on the same side as the root, like we had here, or would it be better to have this root by itself, like we had here? Good, get the root by itself. So, first things first, take this x to the other side, right? So minus it. So what do you end up with? Good, 3. Yay, the x's drop out. I know, right? Okay, looking nicer. Now what? Yep, add the 1 to the other side. Like, oh my gosh, this is looking really nice. It is looking really nice. I'm appreciating this problem. And there's one more step we could do. Yeah, I could literally divide both sides by 4 to get rid of that 4. And this side would just be a 1. I'm okay with that. And that is a really nice problem. So talk to me. What are we going to do at this point? Yes, you are going to square both sides to get rid of that radical. Great. Good job. And you end up with 1 equals x minus 5. And then add the 5 so you get x is equal to 6. Yay! Are we done? You're like, no, I don't want to check it. I get you don't want to check it. But the checking should be pretty easy. As long as we did it right. Agreed? Okay. Go back to the original. This is x plus 6. X plus 3. X is 6. Yeah, so this is 9 to the 1/2 power. Minus. X was 6, so 6 minus 5. 1 to the 1/2 power is equal to 2. Okay, the 1/2 power, or the 1/2 exponent is the square root. So what's the square root of 9? 3. Square root of 1? This answer is good to go. Check. Cool? Okay, recap. I didn't like these exponents. It was easier for me to see them as radicals. If I have to square them, I don't want 2 radicals on the same side. I'm going to move one of those radicals over and then square it. And yes, I had to write it out twice. I had to be cautious on the 2 distributions I had to do, collecting like terms, and then plugging it back over here, and then finish the problem off. Good? Okay, rewatch this one if you need to, because I think the other ones you're probably pretty good on. But rewatch this one if you need to. Have fun with it, and I'll catch you on the flip side.